Okay guys, a rock is thrown straight upward with an initial velocity of 29.43 meters per second as shown on the graph. Label the velocity at each second. What is now this stuff right here? But we're going to ignore, we're going to do this last. So the first thing we're going to do guys is on the graph label the velocity at each second. Okay, let's do that part first. So we know what the initial velocity is. Now, whenever you say, I've got an initial velocity, you've got a VYI. In this case, it's going to be 29.43 seconds. Oh, I'm sorry. Let's just use the eraser. That's going to be meters per second, sorry. Now, whenever you say you have an initial velocity, that's the same thing as saying that that is your velocity at time 0. So this is initial. Whenever you hear initial, think time 0. And so I'm just going to write off to the side because I'm not going to have enough room. 29.43. That's going to be meters per second. It goes in that blank. So now let's find it at time 1. Well, remember guys, just like the amount of money you leave the house with every day, that was always going to stay the same. The initial velocity, what you left the house with. You left the house with an initial amount of money, like let's say $10. Throughout the course of the day, no matter what your actions are, they don't change the initial amount of money you had when you left your house. So this initial is going to be a very important value for all of our follow-up calculations. So let's take a look at a calculation at, let's say, time equals 1 second. And that's going to be for this location here. Time equals 1 second. So now, this object's going to go up, and as it goes up, does it keep going up? No, it's going to slow down. There's something pulling it down, and just like when you jump, there's something that's always going to pull you down, and that is going to be the AY or G, the acceleration due to gravity of negative 9.81 meters per second squared. So every time you try to jump, maybe you're trying to dunk a basketball, what's keeping you from getting as high as you'd probably really like to is going to be the force of gravity and causing this acceleration due to gravity, and it's going to pull you down. Okay, so we've got 3 things. We can solve for the 4th. In this case, you're going to look for your VYF, and that's going to be unknown. I'm going to change my colors real quick to red. Scroll down, give myself a little more space. And you're going to pick a formula out of your list of formulas. Remember, you've got, and I'll list them off, VYF equals VYI plus AYT. That's one you're going to use. And you also have DY equals VYI T plus 1/2 AYT squared. And the always fun but seldom used VYF squared equals VYI squared plus 2AY dy. Now once again guys, don't be afraid by these y's, just telling you what axis I'm working in, what axes. So now you can take a look. You notice guys, these values don't have displacement, so you can cross off these bottom 2 formulas. We're going to be using the first one. So VYF equals VYI plus AYT. And let's just plug in our variables. Now remember guys, we're dealing with time 1. So I'm using the first formula, VYF equals VYI, which is 29.43 meters per second, plus your acceleration, negative 9.81 meters per second squared, times time, which is going to be 1 second. Okay, so what you end up doing, let's plug this in your calculator. You're going to go 29.43 plus negative 9.81 meters per second squared times 1. And that's going to give you VYF equals 19.62. And when we come up here, meters per second, that's going to go into this portion of your graph right here, 19.62, and that goes in there, meters per second. Let's do the next one. Now for the next one guys, you're going to go on to time 2. The only thing that really changes guys is this is going to be a time equals 2 seconds. So I can just come down here and get out my eraser tool and erase this. And now I'm just going to come back and write in a 2 there. Okay, and this value down here, well, that's going to change a lot. Or maybe a lot, not a lot, but a little. So now you're going to replug this in, and I'm just going to hit second enter on my calculator and do that real quick. And you should get a VYF equal to 9.81 meters per second. Okay, and that goes in here. 9.81 meters per second. That's right there. Now, guys, if you want to do this pretty quick, you can do this on your calculator, but, you know, Mr. Shaw always likes to make other things do my homework. I'll show you real quick, guys, how to make Excel do your homework. So let's bring Excel over here and put it in the very center. So here you go, Excel. It's a program, comes with Microsoft. I'm going to put in my time. I'm going to make a time column. I'm going to make an acceleration column. I'm going to make an initial velocity column. I'm going to make a final velocity column. Okay? So let's plug in our times. We have 0, 1, 2, 3. Let's just go down to there. And your acceleration, guys, is always negative 9.81. I made a mistake. Negative 9.81. Negative 9.81. I'm just going to stop there. I'm going to delete these. And you'll see why in a second. I'm going to do a neat little trick. Now remember, from this problem, your initial velocity is always this. It's never going to change. So it's going to be 29.43. That's positive. 29.43. Okay. Now let's drag these down. You see this little cool little square right here, guys? It does a nice little feature. And you can drag this down, and you can get this. Okay, so now, like, okay, Mr. Shaw, you've just filled up some what we call cells. Well, I'm not quite done. Now, in this particular cell, I'm going to put my formula. Now, remember, we used this formula, this one right here. So I'm going to just basically make that formula in the cell. This cell is going to equal this formula. So let me pull it over here. So I'm going to go equals my VYI. My VYI, well, that's right here, plus A. And now when you do, on Excel, you do multiplication, you use this function right here, the asterisk, and multiply by time. You hit enter, and then you come back here, and you just drag it down, guys. Watch. It's right here. You come right here, and you just grab this right there, and you drag it down, and you'll see you get the exact same values that we were getting when we were calculating them just a minute ago. So this is a very, very fast way of doing this. This has got all of our values right here. Wham, bam, we're done. Okay, so these are all the values that would go in to fill up the velocities around this chart. Now, one thing really important to notice at 3 seconds, guys, this is something that's very important. Whenever you throw an object up, it reaches a point where it comes back down, and that at 3 seconds, your velocity is going to be 0. And that's when an object reaches its maximum height, stops, and comes back down. And you can see on our calculations, we got the exact same thing too. At time 3, you see that your velocity is 0. Okay. So let's clear this back off. Okay. So, let's do some of these. Well, the acceleration of the ball, that's a good question. What is the acceleration of the ball going to be, guys? Well, the thing that's important about the acceleration of the ball, guys, is that gravity is always pulling this down. So you don't have to worry about that changing. Gravity is always the same. When you jump up, gravity doesn't decrease. It's going to stay the same. So you are going to keep a negative 9.81 meters per second squared as your gravity everywhere you go. Okay, so let's do a couple of these that are pretty critical. Let's do C. Now, C is actually a significantly tough one because it does a speed. So remember, guys, speed equals the absolute value of velocity. So it says a speed of 15 meters per second. So that means velocity can, in fact, equal plus or minus 15. Now you might say, well, before we could always say it's going down, but this one actually goes up. So you'll have to actually solve this twice. You'll have to find a VYF of 15 meters per second. That's positive, and you'll have to find a F equal to negative 15 meters per second. And what you'll find is this. Remember when we did this math here, guys? Take a look. If you notice, you're going to have a value, but do you see these two values right here, guys? Between them, there's going to be a positive 15, and between these two, they're going to be a negative 15. So between seconds 1 and 2, you'll have a positive 15, and between seconds 4 and 5, you'll have a negative 15. So between 1 and 2, so somewhere right here in this displacement, you'll have a positive 15, and coming back down, somewhere in this value right here, you'll have a negative 15. So positive 15. And then negative 15. And I'm leaving my meters per second off because I don't have much space. I'll put it here, but I feel like I should. Okay, so you'll get it at 2 different locations. Okay. and two different displacements, and you'll actually get a very, very interesting result. So it says find the time, though, required for this. Well, we know what our final velocity is. You know what your initial velocity is. Vyi equals 29.43 meters per second. And we know what our g, we know what our acceleration is. We're getting pulled down by gravity. I always forget that. It's getting a little late, so I'm making a couple mistakes. It's always going to be negative 9.81 meters per second squared. So let's make a diagonal here that I do everything on one side. So I need to solve for time. Well, I'm going to use a formula. I am missing time. I don't have d, so that limits my choices of formulas down to basically just 1. I'm going to have to go vyf equals vyi plus ayt. I'm going to solve this for my time. Let's go 29.43 meters per second equals vyi plus, oh, I do know this. Oh, sorry, guys. Let's, in fact, erase this real quick. I know my VYI. I don't know what I'm... Oh, my goodness. I am making tons of mistakes. Let's start over. Again. All right. Forgive me. So what we're going to do is we're going to say our VYF is 15 meters per second. Some of you guys are probably looking at me very funny at the moment. And you're going to say your VYI is 29.43 meters per second. And you're going to say that your acceleration is negative 9.81 meters per second squared. And I'm going to go over here on this other side, even though I put up the barrier to keep me from doing it. And I'm going to have my time. I'll put in parentheses just for fun. So we're going to subtract. So you'll get subtracting this from both sides, because we have addition here, guys. And how do you undo addition? That's with subtraction. So you're going to subtract 29.43 from both sides. So 15 minus 29.43 gives you a value of negative 14.43 meters per second equals negative 9.81 meters per second squared times time. And then you're going to divide both sides because you have multiplication here. How do you undo multiplication? You do that by division. Divide by negative 9.81, and you should get a time equal to 1.47. But once again, we're not done, because once again it's at speed. Now here's the first point when we have that speed, and that's when we're going up. When we look here we have positive 15 meters per second. And over on this other side, when it comes back down, we'll have negative 15 meters per second. So how do we get that? Well, the same formula again. You get your VYF equals VYI plus AYT. Just plug everything in. This time it's not going to be positive 15, though. It's negative 15 equals 29.43 meters per second plus negative 9.81 meters per second squared times your time. I'm not going to solve this because we just did the exact same problem, but you're going to start off by subtracting this from both sides and then dividing this to both sides, and you'll get to t by itself. So you get a different time. Okay, I'm just going to stop there. I think this should be pretty fundamental, guys. If you have questions, just post a question on Facebook about it.